Please welcome Sebastian Bergmann.
Morgen. So, good morning and hello. This presentation is titled So You Think PHPUnit because the idea of this presentation is to talk about some smaller and some not so small features that are often overlooked, and every week I work with different teams that use PHP to build applications and use PHPUnit to test their applications. And there are a couple of features that I always notice that they are not using. Sometimes those features are new, so it's okay that they don't know about them yet, but sometimes these features are like 10, 15 years old. And this gave me the inspiration and the idea to make a presentation about these smaller features that I think everyone should know because they can really make your life easier. But considering some of the discussions that I had already at this amazing event over the last 2 days, I'm now wondering whether I should have named this presentation So You Think You Can Forget PHPUnit, because some of you, a lot of you, nowadays use PEST instead of PHPUnit, and that's perfectly fine. But just to make sure that you are aware of that, under the hood of PEST there is PHPUnit, and PEST is just an extension on top of that and a wrapper around it. So with that out of the way, and since I was already introduced by Kaneko, I can skip some of the boring stuff. So hi, my name is Sebastian. I'm old. I started doing things with computers a long time ago. I'm doing PHP since 1998, open source since 1998. Started to work on PHPUnit almost 26 years ago now, and back then I would have never imagined that so many people would use that. So thank you for that. And since open source does not put food on the table, I started a consulting company in 2009 with two good friends from the PHP ecosystem. We help you build better software using PHP, and that's all the ad that you're going to get from me today, at least until the end of the presentation, maybe. So, talking about features that not everyone knows about, first one, well, code coverage is something that probably a lot of you already know about, but there are some really interesting small features in there that can make code coverage even better. So, for example, and maybe you have seen that at some point already, you can make it clear, you can make your intentions clear in your test code, what you intend to cover with this test, what you intend to test with this test. And you do that with the covers class attribute. Here we are testing something that is called camera. That's why we are having a class that is named camera test. And we make it explicit, telling PHPUnit that we are interested in a unit of code that is named camera. And then we can run our tests and generate a code coverage report, for instance, and then PHPUnit tells us that it considers a test to be risky because code that is not intended to be tested by this test class is executed while we are running these tests. And this is why PHPUnit considers this test to be risky. Risky test is not something that you need to really freak out about. Oh my God, my application does not work. It's like, think of it as a pointer, as automated feedback from your test framework while it is running your tests, trying to help you. And this means, okay, you told me, the test framework, that you're interested in that. While running the tests, you also executed code from this. Is this okay? If you truly think, yes, this is okay, because whatever it is, matrix, that is a value object that represents a matrix. There is no point in replacing that with something that looks like it, like a stub, for instance. And it's perfectly fine to execute from that and just tell PHPUnit that. Another response would be, oh, I need to think about that. I forgot to stub a dependency. I need to do that and go from there. In this case, we decide that it's okay, and we just put another attribute there, uses class, and then the test is no longer considered risky. If we look at the code coverage report for some application, for instance, and only run tests that are attributed to be large, Large tests are things like really large integration tests or end-to-end tests. And if we only run only the large tests, then in this case, the code coverage report will be all green. That's nice, but it's a rather light shade of green, indicating, hey, these lines of code are executed while your tests are running. The tests are successful. These lines are covered by tests, but the tests that cover these lines, they are large. They may or may not be explicitly testing and verifying that these lines of code work correctly. They are executed, no problem happens, but you probably also want to cover these tests, these lines of code with smaller, more focused tests that provide more precise feedback. We get a different picture if we run the test suite for this application again, but this time only run the small tests. And we now get a darker shade of green telling us, hey, the tests that exercise these lines of code, they are really explicitly interested in these lines of code and verify them. This gives us a higher confidence in there is really nothing that we forgot about to test there. However, line 116 is now red. It's no longer green. This is a line of code that we just discovered that we so far only test through our large end-to-end test, but forgot to test so far using a precise, focused, small unit test. And of course, if we run all the tests, everything will be green again. For all lines of code, we get a dark shade of green telling us these are precisely tested, these are focus tested, and only the one line, the 116, has a light shade of green telling us, hey, you are missing a unit test there. There is not only line-based coverage that PHPUnit supports if you're using Xdebug to collect the raw code coverage information when you're using PHPUnit to run your tests. You can also collect, sorry, this thing is going away. You can also collect more complex and more in-depth, if you will, software metrics about code coverage like branches and paths. And it's really easy, well, at least a lot easier to get to 100% line coverage than it is to really cover all your branches and paths. And you can get a report like that that looks at all the different if statements, for instance. Do they always evaluate to both true and false in your tests? And that gives you more insight into what you're doing there. And for this example, for instance, we have 100% line coverage, but branch coverage is also 100%, but we have a couple of uncovered paths that we may have to look into. If you want to know more about what those paths looks like, you can visualize them through additional tooling. Unfortunately, I do not have that much time today to go into all the interesting details about how to get that data, how to visualize that data, and what it all means. But your first aim should always to go for a really good line-based coverage, and then for parts of your application where you really care about that it works correctly, it may be worth a look into more detailed branch and path coverage to cover all your bases there, so to speak. Okay, I already mentioned that we can select which tests are run. So in the previous example, for instance, we once ran all the tests that are unit tests and once all the tests that are end-to-end tests. And this is something that is very common in the everyday work with PHPUnit. You do, at least I don't know about you, but for me, I do not always want to run all the tests for the project that I'm currently working on, because that usually takes like half a minute, 45 seconds, or things like that when I work on PHPUnit. And that is too long for a really short feedback loop of I make a change, I want to run the test, get feedback on what I have just changed. And for that, it's really nice to know how to select the tests that you want to run. So in our example project here, we have under the tests directory two other directories which are named integration and unit. And one of the most common ways, because PHPUnit gives you different ways of organizing your test suite, one of the most common ways is to use a directory structure to on a high level, structure your test suite, for instance, into categories like unit tests and integration tests, and have different root directories for that, and then you use different test suite elements in your XML configuration file, give them a name, and that allows you to tell PHPUnit to give you a list of all the test suites that you have with a name. In this case, --list suites gives a text-based output. You can also get an XML-based output if you want to do something with that information programmatically, for instance. And in this case, we have an integration suite with 5 tests and a unit test suite with 172 tests. Sorry about that. And then you can use the --test suite option to select which test suite you want to run. So, for instance, when I work on a project, I usually run all the unit tests after every change that I have made to get a really quick feedback. Okay, I did not break anything that worked 2 minutes ago. Gives me the confidence to continue working. Of course, once I am done with whatever I'm currently working on, I run all the tests before I commit and push. But this is my quick feedback loop. --test suite has an opposite, --exclude test suite. So you could, for instance, say, run all the tests that are not in this particular test suite. In this case, it would run my end-to-end tests, or integration tests, rather. There's a different way of organizing, or an additional way of organizing your test suite, which is adding tests to a group, or one or more groups, to be specific, using the group attribute. And of course, there's again list groups, which gives you a list of all the groups and the number of tests that is in that group. And you can say, hey, --group small, run all the tests that are attributed to be in the group named small. Yeah, and once again, there's also exclude group. Just for completeness, because it's not as common, but it is common enough to warrant a special CLI option for that. Run all the tests that are not in that group. For instance, one common use case for that is that teams attribute tests to be in a slow group or in a group named database or something more specific than that, and want to run all the tests that are not slow locally and only run the slow tests in the CI pipeline, for instance. You can even get a list of all the tests, just for completeness, and you can filter tests based on their name. And based on the name means you can be very specific, for instance, test class name, ;:; test method name, and that will somehow match the test that you want to run. In this case, we're running all the tests from the class camera test. In this particular case, because camera test is occurs only once, not in different namespaces, for instance, we can just use camera test and it will execute exactly the same tests. Yeah, and you can also pass just in the name of a test method, and then it will just run that one test. And don't have an example for that, but I should probably mention that you can also pass a regular expression, and it will run all the tests where the combination from class name and method name matches that regular expression. I personally have never used that, but some people find that very useful, which is why I implemented that. Something that is also sometimes useful is, please run all my tests that execute code from a specific class. --covers class name runs all the tests that have a covers class attribute targeting explicitly the camera class. Not really the opposite, but related to that, you can run all the tests that make it clear that when they are run, code from matrix is run, so -- uses matrix. This is useful, and I use it a lot. Like, I make a change to a value object or a small helper object that is used all over the place in my application. I run the tests that explicitly test that. They are green, that's fine. That usually gives me enough confidence, but I get even more confidence when I say, hey, please run all the tests that indirectly also exercise this class or method. And that's what -- uses is for. A lot has changed over the last couple of years in how you can customize the output from PHPUnit. So for instance, we now have a -- no progress CLI option because some teams do not want to see the ... progress printer because they are just interested in which tests have failed. That is what no progress gives you. Please don't ask me why you would want to use no results. Somebody asked for it. It took like 3 lines of code and writing an end-to-end test for PHPUnit to implement that. So I did that. People tell me we use that in CI because we don't have enough space on our disk for the long output in our log files, and we only care about the shell exit code. And for that, probably even more relevant is then no output, because then you only get the shell exit code and nothing else. Right? Okay. What I personally like to use a lot, especially when I'm doing test-driven development, is -- test docs. This is built on the idea that the name of a test should precisely and concisely describe what this test is about. And there's a temporal aspect to that. When you do test-driven development, you write the test first. You take a step back, think about which aspect of the system you want to implement next. You come up with a name for that test that will test the feature once it's there, but here and now it is a specification and description of what you are about to write. And afterwards, you keep it as executable documentation with an example of how this new aspect of the code can be used. And to me, that's tremendously helpful, and that's why I like to use that a lot. If you want to look into what is going on inside PHPUnit while your tests are running, you can use -- debug. Since PHPUnit 10, we have an event-based system under the hood of PHPUnit. Basically, for everything that PHPUnit does, an event is emitted. All output that comes out of PHPUnit, be it output on the CLI or output that is written to log files, that is now all based on events, and you can subscribe to these events and do something with them. And this is just the debug mode where all events are printed. And sometimes this is useful, like when you have thousands of tests, you run your tests, and some test in the middle causes your PHP process to crash, and you don't get output which test caused that. Then you can use -- debug, and the last thing you will probably see in the debug output is, PHPUnit prepared the execution of that specific test. So you can look into that test and will immediately see, okay, this test is responsible for this crash. Now I can start debugging and hopefully submit, not a pull request. Pull request would be even more appreciated, but submit an issue to the PHP development team, hey, I found a seg fault. Yeah, things like that. Something that I would have never thought of, that I would spend so much time of my life and working on PHPUnit on, is dealing with deprecations. And this was basically now it's 2025, that was basically my 2023. We shipped PHPUnit 10, and then I thought, okay, I will never ever have to deal with e-deprecated, e-user deprecated, e-notice, e-warning, and so on ever again. And then people started coming at me with really good feature ideas, and I implemented most of them. So before PHPUnit 10, PHPUnit only had one outcome. A test could either pass or fail or be considered risky, and that was a mess. Now we have 5 types of outcome: passed, errored, failed, incomplete, skipped. And in addition to the outcome, there can be issues. You called a method in Laravel that is marked as deprecated and will be removed in the next major version. You called a function in PHP that is deprecated and will be removed in PHP's next major version. Things like that. And you get really detailed output of that and can act on that. So for instance, if you have your own code, your first-party code, and that's one of this feature that I'm about to show you, that's one of the reasons why you can and should now configure in your PHPUnit XML file which code you consider to be your own code, your first-party code. So our own code triggers a deprecation, but also calls code in a third-party class in a dependency that we have in our vendor directory. This is our third-party class that does something. And then we have a test, and that test calls our code triggers a deprecation, our code calls code in a third-party library dependency that triggers a deprecation, and so on. And you can configure PHPUnit in many different ways, and I could probably talk for 2 or 3 hours just about what you can do here. The takeaway should be the defaults are considered to be best practice and what is the right thing to do in 99-point-something% of the projects. So I will not bore you with those details. So we are ignoring certain types of deprecations by default, and when we run that, we get this output, hey, one test triggered one deprecation. This is there. This is where the deprecation is in first-party class.php on line 12. This is the message from that deprecation, and it was triggered by this test. And of course, one deprecation in your code that you test can be triggered by multiple tests, because multiple tests can exercise and execute the same line of code. But that will be reported only once, because the deprecation exists only in a single line of code, and then you just get a list of which tests are responsible for triggering that. There will be deprecations that you do not want to deal with, at least not right now, and you don't want to see them every single time you run your tests. That's why PHPUnit now has a baseline functionality. You can write a baseline file, and everything that is reported as a deprecation in this run will be written to that file, and in subsequent runs, when you use that baseline, deprecations that you have seen before will be ignored. Of course, you should aim for an empty baseline eventually. So I already mentioned best practice configuration. There is a handy CLI option in PHPUnit --generate configuration, and that does exactly what the name suggests. It generates a PHPUnit XML configuration file for you with best practice defaults. It asks you only a couple of questions. Where is your autoloader? In most projects that will be vendor/autoload.php, it asks you where are your tests. That's usually the test directory. Where is your code? That's usually the SRC directory. And where do you want PHPUnit to cache information so that some operations like code coverage reporting, for instance, will be quicker the next time around. And that's usually .phpunit.cache in the current working directory. And then you get a PHPUnit XML configuration file that tells PHPUnit, this is my first-party code. Everything else I consider to be third-party. I want to ignore indirect deprecations, which means deprecations that are triggered in my code, but my code is called from a dependency because there's nothing that you can do about that. And you restrict notices and warnings to my own code. I do not want to see e-user notice and e-notice from code in my vendor directory because I am not responsible for that unless I follow the example of the previous speaker on stage and go fix that and send a pull request, right? So, but by default, you are not interested in that and just ignore that. And you tell PHPUnit where your tests are and how you want to organize them, and then you can just run PHPUnit and it uses the XML configuration file and things are done. Okay. PHPUnit is not alone. There's a whole ecosystem around it, an ecosystem that consists of small extensions that sometimes just add one new assertion that is very specialized, too specialized to be included as out of the box in the PHPUnit main distribution. Sometimes an extension because, hey, my company wants to have test results reported in a log file format that PHPUnit does not support, and once again, it's not generic enough that it should be supported out of the box. Some teams have very specific existing ways that test results should be reported, and now it's really easy to write a small extension that subscribes to the events that you are interested in and generates the output that you need. And sometimes it's completely new features that are added that way, and some features that were added or that began their life cycle as an extension have over time been contributed into PHPUnit itself because they became so popular, and the original author submitted them as a PR to PHPUnit itself. So one small extension that I would like to show you is PHPUnit slow test detector, because sometimes it's useful to know which are the slowest tests and how slow are they in my test suite. And this is just something that you install using Composer again, or as a FAR if you're using PHPUnit from afar. And then you just say, OK, I want to see the slowest 3 tests, and I consider every test to be slow when it takes longer than 250 milliseconds or whatever that is. OK, and then we can run our tests, and it runs the test as normal. You get the regular output. And this extension registered itself to also contribute to output that is generated by PHPUnit. And it puts its output at a very specific point in time before PHPUnit prints that this is the time and the memory that it took to run the tests, and everything is OK. It puts it between progress and results. And it says, well, I detected 4 tests that were slower than 250 milliseconds. And here are the top 3 tests that you might want to look at. One takes 10 seconds, 9 seconds, 3 seconds, and so on. And I have like 34 seconds left, which is good because I'm almost done. You are probably familiar with PEST, and PEST is great, of course. But if you look under the hood, it's an extension for PHPUnit. It's probably more than just one extension to PHPUnit, but it subscribes to PHPUnit's events to generate its output. And it's a wrapper around PHPUnit that allows you to write your tests in a different format than the one that PHPUnit supports out of the box. Now I have negative time left. I'm a computer scientist. To me, that means I have unlimited amount of time left. That is great. That's an overflow or underrun. So, this Friday is the first Friday of February in this year. And every year on the first Friday of February, there is a new PHPUnit major version coming out. And this year, that's no different. On Friday, I will release PHPUnit 12, which, yeah. Thank you, but don't thank me yet or applaud yet for that release, because it doesn't really add a lot of new feature. In fact, it takes away quite a few features that have been deprecated for a while. But still, I'm very excited about that release, which is why I'm doing a 2-hour online session on Friday, and this QR code will bring you to the sign-up form for that, and I would love to see you there, because I will be talking about new features in PHPUnit and how you can migrate to PHPUnit 12. And with that, I'm done. Thank you.
Thank you. Great talk. I got questions.
Yeah, I was about to say, you probably have questions.
Yeah, a couple of them.
I mean, it could be worse. You could have issues.
Yeah, it's always worse. So, first question. What did inspire you in the beginning to create PHPUnit?
Why did I did this? Why did I start this?
Yeah.
Well, I was still at university at the time, and I had a professor who exposed us students really early on, like only very shortly after Erich Gamma and Kent Beck released JUnit, and I was interested in that. And my professor knew that I was doing things with PHP and open source, and he said, well, now can I convince you to do more Java here at the university and more research, because I see that you're excited about this topic of testing and that you like JUnit and the concepts behind that, but that does not exist for PHP, so next weekend I started to work on what would become PHPUnit. Yes.
Ta-da! Thank you. I gotta say, thank you for all your work that you've been doing for the past years. I think you all appreciate it. Not as much as expected, but thank you all. Thank you for amazing thing. I'm still nervous around him.
You do not need to be scared.
I'm not scared. I'm just nervous. It's like meeting a rock star. Yeah, it is. But okay. So, last question is a little bit tricky. It's come from Tiago. He's asking, why was the stop on failure command removed? Oh, shoot.
It was not removed. Stop on failure is still there.
Tiago, what are we doing? Okay, so do you want the trickiest question? What do you think about best?
See, that is one of the questions that I get a lot. And I think I talked about an hour about this with Nuno on his YouTube channel.
Yeah.
So I could chicken out and say, go watch that video. Go watch that video. Yeah, there are many different answers I can give to that. One answer is on a very technical level. I'm thankful that somebody built something like that because that proves that we did at least something right with the event system in PHPUnit because it allows you to hook so deep into PHPUnit that you can change completely the way that the output is presented, plus wrapping around PHPUnit to implement a completely different way of writing your tests while still reusing a lot of code and functionality and features from PHPUnit. And to me, that's what open source is about, right? I built something. Of course, it's opinionated. I'm a human being. I'm not just a name in your console when you run your tests. I am a human being. And I have opinions, and these opinions are reflected in the software that I wrote, because I would like to be the output the way it is, and I would like to write the tests the way that PHPUnit suggests that you write the tests. But if somebody has different opinions and wants to build on my work, great. And for the rest, watch the video.
You pass. Okay. Thank you once again. A big round of applause for Sebastian. Thank you.